Hi, I got a idea that I've actually had for quite a while that I've never really shared to really anybody, or anybody that I shared it with didn't really grasp the simplicity of the idea. But anyway, this is an idea for a power station that uses only water, electrolysis, and the stored chemical reaction of gases. More specifically, the two gases that make up water, hydrogen and oxygen. You see, gases have these interesting characteristics that when you compress them, like say hydrogen, and you compress hydrogen atoms into helium, the amount of energy that goes into the force that puts the pressure to compress them and fuse them, the amount of energy to do that is less than the amount of energy you get immediately after the reaction. You always seem to get this, you have a force that compresses the atom, and all of a sudden you get this ginormous release of energy from gases, and when you compress them. And this reaction, higher output reaction than input, happens all the way down to iron in stars. And that's when the amount of energy put into compressing iron, the output that you get is not as much. In fact, it's much lower than the output that you put in. You have to put in more energy in to get to compress iron into a denser material than you get out. And that's when the energy renewable effect of gases compressing into deeper, denser gases dies. That's when all stars dies, when they create iron. Now, knowing these characteristics of gases, we have a direct relationship with oxygen and hydrogen, which is very convenient for us because of this characteristic of having potential energy from combining two gases to get this reaction, get this energy reaction back. And this idea is got to be one of the simplest ways to have a setup for a power station. It starts out, we all know, there's probably layers under the Earth's crust. Like if this was the surface of the Earth, we have certain distance or depths where we have reservoirs of water. And most people think that this is probably due to the buoyancy of water. When it sinks into the ground, the gravity, decreases as it sinks, and there's probably a level where the buoyancy of water, it doesn't sink anymore, and that's where all the underground water reservoirs are. And most people have the concept and the idea that they want to use this water for some usefulness, so they drill shafts, well shafts. But I have the idea of, instead of making one well shaft in the ground, let's put it in the middle here. Well, you have one well shaft that goes down to wherever the layer of water is. Let's say it's here. Say each one of these lines is like 100 feet into the ground. So we're going, say 600 feet, and then this is the level of the water reservoir right here. Now, instead of having just one shaft and having to pump the water up, the heavy water physically up one shaft, I came up with the concept of making two shafts. And you have both of these shafts very close to one another, as close as you can, and you need them to exceed the surface of the reservoir as well. They both have to go below the surface line of the reservoirs. It's very important in order to do the extraction of what we want to do next. Instead of pumping the heavy physical water out of the reservoir, what we're going to do is, on the surface during the daylight hours, is we're going to use solar arrays. The bigger the solar array, the better. So as you have solar arrays up here, which supply a DC current, the exact type of current needed for this process, is what we're going to do is we're going to perform electrolysis in these two shafts with solar arrays. You're going to have the solar arrays all hooked up, so you have one large positive, one large negative. Whatever voltage is obtainable by whatever equipment you have available. Say you have 1,000 watt panels, whatever, so this could be 6,000 watts. Here's the plus, here's the negative of solar array, and you take those electronics and you hook them up to individual shafts. The plus gets one shaft, the minus gets the other. Now, when you sink these ends of the solar array into the reservoir, they cannot exceed the level in which the shafts end. The electrodes must be below the surface line of the reservoir, but they must not exceed where the ends of the shafts actually are underneath the reservoir level. The electrodes from the solar array must be in this area here only, because we cannot have a risk of potentially leaking the oxygen or the hydrogen gases that are going to be produced by our electrodes to leak into the reservoir under the ground. We could have bubbles of hydrogen and oxygen accumulate under the ground, and we don't want that. So what we're going to do is we're going to now, instead of pumping water up these shafts, what we're going to do is we're going to take air pumps, and we're going to hook them up to these shafts, and we're going to pump up, and it'll be a lot easier because these two gases are much lighter than water. You know, if you perform electrolysis in water, you get bubbles that begin to go up to the surface of the water. And this is called electrolysis. It's been known ever since Volta made the first battery back in the day. It's been known for a long time that you can do this with water. I forget which one is which. I think it's the positive is like the hydrogen, the negative is the water, or something like that. But anyway, you get twice as much hydrogen bubbles as you get oxygen bubbles. And what you're going to do is you're going to take the gases now, instead of the liquid water, you're going to take the gases with air pumps, and you're going to feed those in to compressed air tanks, right? I got one right here as an example, because this is more like a power plant that uses solar and electrolysis with water in underground reservoirs to build up a storage amount of potential energy from chemical reactions of gases. And so basically, instead of trying to charge up battery cells, large battery cells with energy, what we're going to be storing is the gases in tanks like these. Like, this is just a basic tank for, like, firemen or whatever, but the amount of pressure that can be put into this tank is enormous. Like, see, this gauge is, every number is a representation of 100 psi. So this 5 right here is 500 psi. It'll go up to 30, which is 3000 psi. That's a lot of pressure. I mean, considering a normal car tire is about 40 or 50 psi, and this 5 represents 500, which is the lowest point on this air gauge. And this is an air, this will compress air, which is pretty much oxygen. And there's nothing wrong with using a tank like this to store and compress hydrogen, because it's a gas as well. It's just oxygen and hydrogen are gases. And the way you capture them is with tanks like this. It makes it really safe to have them in tanks like this, but you still cannot have them be exposed to like flames, or they're very flammable. I mean, people are scared of using hydrogen gas as a way of storing energy because of the Hindenburg and things like that. If you use them correctly, it can be used as a very useful way of storing energy from the sun. See, this is what I believe this is going to do. What this is going to do is you're going to use solar during the daylight hours to collect the sun energy, which is always enormous during the daylight hours. No matter how big, you can have one solar panel even produces quite a bit of power. But if you've got an enormous solar array, all of the energy that you're collecting with that large solar array is going to go into the electrolysis that you're performing in the water. So the higher the energy amount that you put into your electrolysis chemical reaction you're doing here, the more potential stored energy you could have in the tanks by the end of the daylight hours, right? So the more power you put into the electrolysis here, the bigger the solar array, the more power into the chemical reaction you're doing here, the more power you're going to be able to get back out of the two chemicals when you recombine them later, after the sunlight hours are done, when it's nighttime, when the sun has setted. See, that's how this is going to operate. When the sun is coming up, it's like basically you cannot have a time or a point where you're storing energy and taking out energy out of the system at the same time. This is either storing energy at one point, or you have to stop storing energy and then you start using energy. You can't do both at the same time with this setup. It's only one or the other. So, real simple. The amount of energy you put into this chemical reaction down here is basically that energy you're putting into that chemical reaction is what energy is going to be stored in the two gases for later. See, the energy effect that went into creating these gases, more specifically the amount of energy that you're collecting with a large solar array, that energy from that large solar array is being put into the chemical reaction of these two gases. So you could end up, however much power you put into that reaction, the more energy you get stored into the gases for the reaction later. See, what we're doing is we're using our intelligence and our awareness of chemical reactions of electricity, water, oxygen, hydrogen, and how the chemical reaction of gases, the characteristics of combining gases and getting this enormous amount of output you get for a very small input to combine gases. Like, gases are so light, it doesn't take very much energy at all to combine them into water. Like, in fact, by doing that, you get an enormous amount of energy out than it takes to combine the oxygen and hydrogen into water. You get water as a byproduct, and you get energy output, high energy output, as another byproduct by combining hydrogen and oxygen together. And it's really interesting too. The more cleansingness you can get in this process, I mean, the purer the hydrogen, the purer the water, the more pure, basically the cleanest you can make this operation, the more efficient it's going to be as well. It means if you can make the cleanest water, or if you collect the cleanest water, make the cleanest oxygen, the cleanest hydrogen, you will have the most efficient amount of energy output by doing it that way. By having impurities in your water, and by having those electrolysis effects taking place within your power station here, you can dilute your energy output, basically. So it puts motivation in a power station like this that you want to have it nice and clean as well, as pure as possible. And why wouldn't you? I would want my water to be as clean or as pure as possible, especially if my power station relies on it to operate. So, real quick overview. Solar array. 2 well shafts instead of just one. Instead of using electric pump to pump water, you're going to be using air pumps to pump the oxygen and the hydrogen gases that you get in these shafts from a solar array electrolysis done to water reservoirs under the ground. This way, you can only have to pump out light gases instead of having to pump out heavy water. Those gases during the entire daylight hours are captured by the sun and put into compressed tanks during the daylight hours. Once the daylight hours are done, then the solar array shuts down, the electrolysis process stops, and then the recombination of the hydrogen and the oxygen and energy output now can begin. The storing of the energy is over during the daylight hours is through, and during the nighttime hours, when you need energy the most, you now have it completely stored up in the form of 2 gases, oxygen and hydrogen. And with gases, if you can have high energy output by condensing them together, and by previously knowing that by taking hydrogen and oxygen and putting them together, you get that energy output, plus you get a byproduct of clean water. We all know that chemical reaction. So this is a loop of energy, being able to capture energy, store that captured energy, and then being able to reuse that energy in the form of gas characteristic chemical reactions it has with itself. The energy output you get from chemical reactions of gases is what we're using as our storage of energy from sunlight. This is all coming from sunlight. The enormous amount of sunlight that we're exposed to every day is just enormous. It's like the amount of sun, if we could capture like a 1/100th of the sunlight and store it some way, we could have an enormous amount of power at our disposal at night or whenever we need it. And battery cells are just not going to cut it. The lead acid, those, it's just never going to work. We need a more practical solution, and this is it. Instead of storing electricity in the batteries, we want to store gases, potentially, energetic gases into tanks like these for potential gas chemical reactions that give us energy and clean water. It's really, and that's all, and it's amazing. And all this does is a looping process of turning water into gas and then back into water again. And the energy that you use to do this process with couldn't be any cleaner than pure sunlight. So this is a very, very clean and very efficient way of collecting and storing energy. And it has to do with the most fundamental physical thing that is essential for all life in the universe, and that's water. So there's nothing toxic about this process whatsoever. It's just taking water, turning it into gases, storing those gases as the sun goes. Once the sunlight is gone and you can't store anymore, then you take that storage gases and you recombine them into water. And as you do that, you get that chemical reaction that gases give you when you compress them together. Basically, that energy that you put into the electrolysis process here during the daylight, the energy from the sun that went into that process, is making those gases, the energy in those gases, basically a storage of that energy that went into that process. So the more energy put into the electrolysis process, the more energy storage possibilities could be attained. You know what I mean? So the bigger the energy you put here, the bigger the storage of the gases that you can put there. So there really is no limit to how much gas you can store. It's just the size of the tanks and how much water is in the ground, and the potential to build it. So I think that there's really no idea of a simple power station like this anywhere. Geothermal is good, but having to use steam to run a turbine really can be difficult to maintain after a while. As you can see in this does not have, the only moving parts in this entire process are the air pumps that suck out the gases from the shafts. That's the only mechanical process that really needs to take place here. Everything else can be just, connections of pressure pipes, anything that you use for water pressure washers, compressed air tanks, all of that technology can be used, with like gas and compressed air technology can be used as water pressure and pressure washer technology. They're both pretty much the same thing, and that's what this is going to be using, is those type of materials: air tanks, pressure washer materials, solar arrays, shafts. And it's a really much more elegant way of being able to store power that you're getting directly from the sun. You're collecting sunlight, and storing that captured sunlight in the form of gases, and those chemical reactions you get in those gases is the reaction that you get from the stored here. So, okay, I don't know what to really call this kind of power station. It's like the water looping solar array power station or something like that. The only way to make this work is if you have a constant stream of sunlight, a reliable stream of sunlight all the time. If anything ever happened to the sunlight source, then this power station is no longer available. So as long as we have a sun, as long as there's a light source, a sunlight source, and as long as there's a big enough water reservoir under the ground, and we can make gases under the ground with the water, pump them up, and use them to store energy, for as long as those materials are there. And there's nothing toxic about water to life whatsoever. Even though the hydrogen and the oxygen gases are very flammable and very explosive, They are not to be feared, because that energy is the stored energy that you're getting from this original electrolysis reaction. So I don't know if I'm ever going to be able to make one of these. I will try to make like a model of this with, with like, somehow should have a model built reservoir underneath some soil or something like that, and try to prove that this process can be possible. But it doesn't seem like it wouldn't be impossible, because it's just all the technology that you're using is, for air compressing, water compressing, anything like that whatsoever is pretty much the same technology. So there is no unknown technology that needs to be constructed for this. It's all really known, simple. The only thing mechanical are the air pumps. The only thing that you need are the natural resources of the planet, and the cleanest thing we could ever want out of all natural resources, which is water. And the cleaner you get this process, the more efficient it is, and the better quality of life you have for the power station population.